from this list of problems. This is all what we did in class, and these. So for now, I would like to consider this reviewed already. So I would like to look at the other sections. And then on Thursday, I would like to start reviewing for the final exam, but I will also go back to any topic you want for this test. So please make sure you finish everything between now and Thursday, and you come back with a list of questions and say, I want to see this, I want to see this, I want to see this. Okay? And I'm hoping that when you sit at home and you work on the MyMathLab homework, you just not look at the websites and stuff and punch in numbers so you can get an answer and punch it in, because it's not going to help. I hope that that's not the case. Okay, so let's look at a problem from 6.1, which you will have to do by hand. Okay, would you like to choose a problem on page 631? Or you want me to choose a problem on page 631? So from this yellow form that I just gave out, I recommend between now and Thursday, everything on pages 1 through 4. 1, 2, 3, 4, 5, 6, and 7. Anything 1 through 7 you can do. And then if you have questions, we can go over them in class. Okay, so on page 631, let's say problem 28, Gauss-Jordan elimination. So 3x plus y minus z equals 0, x plus y plus 2z equals 6, and 2x plus 2y plus 3z equals 10. Let me make sure that I copied it correctly. Sometimes I copy from a number, one equation from one problem and an equation from another. Okay, x plus y plus 2z equals 6. Yes, correct. 2x plus 2y, 3z, 10. Yes. So we are asked to solve the system using a Gauss-Jordan elimination. How do I do this? What is my starting point?
The rows and the columns.
Very good. In other words, write the
Coefficients.
Augmented matrix. Very good. So I need A, B.
3, 1, negative 1, 0.
3, 1, negative 1, 0.
1, 1, 2, 6.
Perfect.
2, 2, 3, 10.
Perfect. This is indeed the first step. Any questions on the first step? Any questions on the first step? Perfect. So now the method is requiring us to have a 1 in here and the corresponding zeros, then a 1 in here and the corresponding zeros, and finally 1 in here and the corresponding zeros. We are only allowed three operations. One operation is swapping rows if I need to. The second operation is divide or multiply both sides of a row by a number. And the third operation is multiply a row by something and adding it to another row. So my first step is to get a 1 in here. So how do I do that? What is the simplest possible way to get a 1 in here?
I have to say multiply and then add. So I don't know for sure.
No, exactly. Indeed, I'm going to make this row the first row and this row the second row. It's one of the allowed operations and it doesn't change anything. Perfect, awesome. So R2 becomes R1 and R1 becomes R2. So can anyone dictate?
1, 1, 2, 6. 3, negative 3, 1, negative 1, 0.
So my first step is accomplished. My first target is accomplished. Good. Now what row will I use to get a 0 here and then a 0 here?
1.
Row 1 will be multiplied by something and added to row 2, and the same row 1 will be multiplied by something and added to row 3. I want 3 to go away and I want 2 to go away. So what will I multiply row 1 by to eliminate this?
Negative 3.
And to eliminate this?
Negative 2.
Do we all agree with this step? Yes? Okay. Which row I copy at this step, in this step, because I'm using it and it will not change in any way?
1.
Yes. 1, 1, 2, 6. Now let's do this together. 1 times negative 3 plus 3. Perfect. 1 times negative 3 plus 1.
Negative 2.
2 times negative 3 minus 1. Perfect. 6 times negative 3 plus 0.
Negative 18.
Perfect. Perfect. Thank you. 1 times negative 2 plus 2.
0.
1 times negative 2 plus 2.
0.
2 times negative 2 plus 3.
Negative 1.
Perfect. 6 times negative 2 plus 10.
22.
One more time.
Negative.
6 times negative 2 plus 10.
Oh, yeah, 2. Negative 2.
Perfect. We accomplished these. Now I'm working on this. What do I want in here?
1.
Yes. What do I have to do to this row to get a 1 in here?
I would say divide by negative 2.
Row 2 gets divided by negative 2. Ugly, but that's what it is.
And then with negative 7 you get negative
So the first row has to be copied. 1, 1, 2, 6. The last row has to be copied. And now can anyone dictate the second row?
0. 1. 3 with 3.5 for 7 halves. 9.
Perfect. So we accomplish now this, 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 this. Oh, lucky me. I also have this. I only need a 0 here. Which row will I make use of to get the 0 up here? The second row. R2 multiplied by something and added to R1. That's why I needed the 1 first to get the 0. I have to use this to get the 0. So what will I multiply this by to add it here and get a 0 here?
1 half. 0.
So I can never multiply by 0. We're never allowed to multiply. Remember, the procedure says only non-zero numbers. 1 times what plus 1 will be 0. Correct. Correct. Good. I am copying 1, 0, 0, and 1, 7/2, 9, and 0, -1, -2. 1 times -1 plus 1. Perfect. Careful now. 7/2 times -1. 7/2 times -1 is -7/2 plus 2. -3/2. Ugly, but that's what it is. Finally, 9 times -1 plus 6.
-3.
Perfect. What did we accomplish? A lot. All this
The
is
first 2 columns, yeah.
good. So now I have to obtain a 1 here. How do I obtain a 1 here?
Divide the row by -1.
That's it. I divide row 3 by -1. Perfect. Good. So 1, 0, 0, 1, 0, 0, 1, 2. And I copy 7/2 and 9 and -3/2 and -3. Okay. So this is all done, but I want a 0 here, and I want a 0 here. And then the whole thing is finished. Which row will I use? Very good. I will reuse row 3, multiplying it by something and editing it to row 1. And the same row 3, multiply by something else and adding it to row 2. In order to get a 0 here, what do I multiply 1 by? And add it here.
-3/2.
So 1 times -3/2 minus 3/2 will not be 0.
3/2.
I agree. 1 times this plus this will be 0.
-7/2.
I agree. Perfect. So 1, 0, 0, 0, 1, 0, 1, 2. Together. 1 times 3/2 minus 3/2.
0.
2 times 3/2 is 3. 3 minus 3.
0.
1 times -7/2 plus 7/2.
0.
2 times -7/2 is -7 plus 9. I don't know for certain, but it appears that the solution is
0, 2, 2.
I have 2 ways of checking. I can go back by hand, or I can show you again how to check using the graphing calculator. Here it is. So let's go to second and matrix. We want to edit the matrix. I want to edit the matrix. It's already there, 3 by 4. Yes, that's what I want, 3 by 4. And I'm going to edit by rows. And it's 3, 1, -1, 0. 3, 1, -1, 0. Next one. 1, 1, 2, 6. 1, 1, 2, 6. And the last row, 2, 2, 3, 10. 2, 2, 3, 10. Get out of there with second and quit. Go back to second and matrix. And now we want to do math with it. And scroll up to RREF, part B. Press enter. Go back to second and matrix and recall matrix A that we just created. And press enter. And if I get 0, 2, 2, assuming I didn't enter anything incorrectly, this would be quite a coincidence. By hand, I got 0, 2, 2. Using the calculator, I got 0, 2, 2. Any questions on how to apply Gauss-Jordan elimination? Gauss-Jordan elimination. Do you think we need another example? You will be able to do this, but it requires some time. You really have to put some time into this. As long as you stick with the steps, you should be fine. Okay, this was 6.1. I'd like to go back to 5.4. 5.4 and 5.5. So a system of nonlinear equations. Any preference? We are on page 587, 588. Would you like me to choose, or you can choose? 588 and 587. Do I get to choose?
Yeah.
Okay. Let's say problem 40. And that is x minus 1 squared plus y plus 1 squared equals 5. And 2x minus y equals 3. The problem is telling us solve, use the method you like. Well, I may like a method, but it may not be applicable. So I should make the correct decision and apply the method that works here. And the methods that we discussed here, not the Gauss-Jordan, of course, but elimination and substitution. So which of these two methods is applicable here? Not Tom. And why? So I would like you to say, only this method works here, and here's why. Or both methods work here, and here's why. What do you think? It's okay if you're wrong. I just want to hear something from you. Not Tom. Only substitution. Perfect, Eddie. Why?
Because you can solve for either x or y and then just plug it into the
Absolutely. I prefer which one to solve for.
y.
Correct, because the coefficient is 1 or negative 1, always. But how come that I cannot apply elimination? The answer is the variables are not the same. You can eliminate. This is x, but this will be something else. This is y, but this will not be y, right? So you don't have the same variables. So substitution doesn't work when you don't have the same variables. You won't be able to eliminate any of the variables. Good, very good. So we decided to solve this equation for y. I'm going to move 3, I'm going to move y. So then y equals 2x minus 3. Okay, so now what do I do with this? So one more time, only substitution. Elimination does not work. Variables are not the same. So, what do I do next? Yes, where? Perfect. I'm going to replace y in the first equation by 2x minus 3. Awesome. Thank you. So then x minus 1 squared plus 2x minus 3 plus 1 squared equals 5. Awesome. What next? What will you say we have to do next? Say it again. Yes. 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 Very good. So I will write x minus 1 plus 2x minus 2, everything squared, plus 5. Perfect. Now, this is as much as I can take it. It is not plus. I'm sorry. Yes, I'm sorry. I don't know why I wrote plus. My apologies. Good. What now? What will be my next step? What type of equation is it, and what will be my next step? It is quadratic. Very good. Awesome. So then,
Together, after you must simplify,
yes. So
so x minus 1 squared is
yes. And let me remind you, we have an agreement for 3 months and a half.
x squared minus 2. Okay, and then minus plus 1.
Perfect. Awesome. Plus.
4x squared
Awesome.
Plus 9.
2 times the first times the second, 8x.
4, 8, okay, 2, 8,
Plus
4.
minus 5 equals 0. Awesome. Very good. Well done. So now, please dictate what will be the next step.
Combine x
Good.
5x squared
Awesome. So these are done.
negative 7.
These are done. Awesome. And 4 plus 1 is 5 minus 5. These are going away. I need to simplify before I continue. And I cannot divide by x, ever. But I can divide both sides by, to make my life easier with this equation, by 5. And I will do that, not by x. You will miss a solution if you ever divide by x. Good. So then I have x squared minus 2x equals 0. What now? No. When the free term is missing, I can only do this in a blink. When the free term is missing, it's the simplest possible quadratic equation. You only factor out the greatest common factor, and the solutions are there. And I will never complete the square unless you force me to. So there are two options for x. Yes, 0 and 2. Awesome. This is good, but it's not good enough because I have to find the corresponding y. But it's not a big deal. So when x is 0, how much is y? Perfect. So 0, negative 3. And now when x is 2, how much is y? That's it. So 2 comma 1. We have to check. So please remember, go back to the original problem and always check solutions. It's very easy to make a mistake. Okay, let's look at section 5.5. Okay, let's look at a system of nonlinear inequalities this time. Yes, 45 caught my eye. I apologize, I no longer have, I omitted to, oh, I do have one more page. Awesome. So this is my page 13. Okay, 45 on page 600. So y greater than or equal to x squared minus 1 and x minus y greater than or equal to negative 1. Any questions? Ryan, can I help? Okay, very good. So the first step, obviously this is a system of nonlinear, this is nonlinear, this is linear inequalities. I have to start by writing the equation. And then I have to graph it. When x is 0, how much is y?
-1.
Thank you. 0 comma negative 1. When y is 0, I have 0 equals x squared minus 1. What type of equation is it, and how many solutions I expect?
Quadratic.
And I expect?
2.
Very good. So you either factor or move and take the square root. So if we factor, how do we factor? We have an agreement on this for 3 months.
Difference of squares.
Yes, x minus 1, x plus 1, so we have plus or minus 1. Good. So I'm going to graph. So this function crosses here and here and here. What type of graph will I have to graph? If you think of transformations, how will you graph this? What is the base function here? Yes, and then
Vertical shift down.
that's it. That's all I have. Perfect. So this is y equals x squared minus 1. This is just the equation. I should have asked, I'm sorry, forgive me, is this a solid curve? Yes, because of the equal symbol, it's a solid curve. Very good. So I see that this graph divides the entire plane in two regions, the inside one and the outside. I'm going to pick a point that is easy to work with, which is 0, 0. 0, 0. Is 0 greater than or equal to -1? If you say yes, then I will shade in the inside. If you say no, then I will shade in the outside. Correct. So then I have all this, which represents the inside, including points on the curve, y greater than or equal to x squared minus 1. I have to repeat all the steps for this, which is x minus y equals -1. When x is 0, how much is y? Perfect. 0, 1. When y is 0, x equals -1. So -1, 0. So here it is. And 0, 1. Before I do anything, I have to ask myself if I have to graph it as a solid curve or line in this case or not. Solid or not? Solid or not? Are we on strike?
Sorry, it's tired.
Okay,
Really
so
tired.
it is solid, right? We agree? Good. So this is only x minus y equals -1. So now I have to extend this a little bit. Good. So I see that the straight line divides the plane into two parts, the bottom and the top. So I'm going to use, because it does not pass through the origin, I'm going to use the origin again. 0 greater than or equal to -1. Since you already told me that that was true, you're not going to change your mind, I'm sure. So this is x minus y greater or equal to -1. So now I have to intersect, because this is a system, the darker green and the lighter green. Do they overlap? Yes. So for this point, this point, this point, everything on the line, all points on the curve, and everything else in between. And this is for both. Any questions? Let me just refresh your memory on what is left to review. Chapter 8, just section 8.1, that's all we did. We reviewed everything else, but I would like you to help me on Thursday and say, I need to still review blah, 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 blah. So then we'll review that you think you still need to practice on. That's very important.